Welcome to everyone to the Elizabeth City State University Summer Research Team's second Ignite presentation on responder safety in austere conditions. We are still in sunny North Carolina, and our team members are still the same. We have not broke anything or done anything silly enough to earn ourselves a call sign yet, so that's one good thing. And we are moving ahead looking at different potential disasters in austere conditions, where we're using the philosophy the only way to be prepared for the unexpected is to expect everything. General data on injuries and accidents really is not existence for this program at the moment. So we are looking at individual cases and root causes for the injuries and accidents. Then we're comparing them to literature and classes for objectives on what these responders would be trained on in order to be able to help others in time of need.
For this presentation, I will be talking about the different sensors and payloads that can be attached to drones that can be used for emergency response applications. In emergency response, thermal sensors can be used to pinpoint source of heat signatures, and this could be very useful in extreme cases of heat or cold to be able to identify the location of a lost person. Though thermal sensors and infrared sensors are different, they have very similar applications in emergency management. They can be used to find heat signatures of a missing person when looking for them in austere terrain. The ability to actively track a responder as they go in situation will be very good because this way you'll be able to watch them and monitor them, and in case something goes wrong, you'll be instantly notified and aware of what's happening. LiDAR could come in handy in emergency response situations. If somebody were stuck in a heavily vegetated area, LiDAR will be able to map out what's underneath the vegetation that we may not be able to see, and therefore we have a better idea of what we're going into or what may have happened.
NASA's Black Marble program makes the use of Visible Infrared Imaging Radiometer Suite, also known as the VIIRS, depicted to the right. This instrument is capable of capturing human-signaled lighting. The image to the left is the process in which Black Marble collects data. This image is of Alaska seen through the Black Marble layer, coastlines, borders, roads. While the image may look barren, the project is still a work in progress, with many layers being adjusted and added. Here is a satellite view of Alaska via Google Earth. Pay close attention to Anchorage, Nome, Prudhoe Bay, as they will be significantly luminous in the progressing image. The layer depicted is the Black Marble nighttime at-sensor radiance day-night band. While Anchorage, Nome, and Prudhoe Bay are rather illuminated, one can also observe the smaller, more austere locations in Alaska. While Black Marble only began data collection this past November, we are excited to see its progress and adaptability to assisting in disasters and austere locations, such as the Arctic. The image to the left is of the Gulf. The tiny dots offshore are underway vessels.
As we move forward and start looking at austere conditions that are provided by disasters, we will start looking at actually what a responder is, and that could be anyone, including your neighbors. The idea here is that we want to maintain everyone's safety. So as we conclude this, we want you to remember that this is important research in order to be able to save the lives of those that would save others. Thank you very much.